Hello everybody, I wanted to make a quick tutorial video on how to solve conservation of momentum problems. This is a strategy that is very helpful. One of the issues with these types of problems is that there's so much information that you want to have a way to keep track of it. And so I recommend this sketch. Here's the problem. A 2 kilogram cart is moving to the right at 4 meters per second, and it hits a 1 kilogram cart that is at rest. After the collision, the 2 kilogram cart is moving 2 meters per second to the right. What is the final velocity of the 1 kilogram cart? Okay, so I recommend just drawing this. So here is the 2 kilogram cart, and I'm going to take note of which one it is by writing above it a 2, because that's 2 kilograms. And it's moving to the right at 4 meters per second. So I draw an arrow and then I write a 4. So I've got the mass and I've got the velocity. The other cart is 1 kilogram and it's at rest. So I write V equals 0 and 1 kilogram above it. Now that's the before. After, I draw the same thing. So that dotted line indicates that the division between the before and after situation. This cart is 2 kilograms. The other cart is 1 kilogram. And now I write the velocities underneath. So I write the masses above, the velocities underneath. This one is now moving 2 meters per second. The other cart is probably moving to the right, but I don't know yet what it is. So V equals question mark. That's what I'm going to write there. Okay, so I have the masses above, the velocities below, and now in a third line, I can write the momentums. So 2 times 4 for this first cart, 2 times 4 is 8 kilogram meters per second. And then the other 1 times 0 is 0 kilogram meters per second. And then on the right side, I have 2 times 2. So this cart has 4 kilogram meters per second. And then this other cart, it would be 1 times V. So it's just V kilogram meters per second. All right, so what do I have? I've got 3 lines of information. Mass is above, the velocity is below, and then even below that, I have the individual momentums. Now, I know by conservation of momentum that the total momentum has to add up to be the same thing on both sides. So 8 plus 0 is 8. That's the total momentum on this side. And this has to equal, now on this side, I can only write 4 plus V. I'm going to leave the units off. Okay, so now I can solve for V. So I say 8 equals 4 plus V. So subtract 4 from both sides, and I get 4 equals V. That means that final velocity up here, V1F, the final velocity of the 1 kilogram cart, is 4 meters per second. So you can see it's kind of like a big puzzle where we've got, again, the mass is above, you write the velocities below the carts, and then you write the momentums, P is momentum, even below that, and then a final line where you're writing the sum of the momentums. And no matter what you're missing, you can fill this out and then treat it like a puzzle, like a logic puzzle. You have to work to find the one thing that's missing. And this is a general strategy that works really well.